Hi there, my name is Matthew Shapero. I work with the University of California Cooperative Extension. I'm the livestock and range advisor up in Ventura and Santa Barbara counties. And I'm really pleased to be able to be with you all today, albeit virtually. I'm also looking forward to being together next week, again virtually, but at least live. Today, I'm going to talk for about 20 minutes, talk about how in California we are studying the effectiveness of grazing to reduce fire risk. And I have to start with an apology entirely because of my poor communication. The subtitle that was present on the flyer for this talk that you can see in parentheses there is really fairly inaccurate. I'm going to be talking only just a very little bit about soil seed banks, nothing about soil biology, and I'm going to be talking more in a statewide context for all of California, not focusing specifically on Ventura County. But with that said, let's get started. I know I just said that I'd be talking about California generally, but I did want to start with this image of Ventura County. Here you can see in red the county boundary. And this is an image from the CAL FIRE database showing fire perimeters for 2 decades, the 1920s and the 1930s. The reason I'm starting with this image is because I think it emphasizes well that what we think of as the fire problem or the wildfire problem is not necessarily anything new to California. California, especially rangelands in California, have experienced fire for a long time. Here in these 2 decades, you can see some fairly substantial fire activity covering large portions of the county. In particular, you can see in sort of the middle center of that image, the boundary of the 220,000 acre Matilaha fire in 1932. And so only, again, just to emphasize that wildfire is not new to rangeland ecosystems. What is relatively new, of course, though, is the relative pace and scale and intensity of fires in recent decades. So this sort of jumbled map is all fires from the CAL FIRE database dating back to 1898 till essentially the present. And what's remarkable in pink, or sort of that salmon color that you see there, are all fires just in the last 20 years. So really just sort of covering almost all of what there is to burn in Ventura County. And in the list there on the left, you see the 10 largest fires that have occurred all time in Ventura County, all time that is in the CAL FIRE database. And what's remarkable is that 7 of the 10 largest fires have occurred in the last 20 years. And so certainly we are thinking more and more about how wildfire is impacting rangeland ecosystems, and especially rangelands that get grazed. We've long thought about how grazing and fire interact, at least as range scientists dating back through the length of the 20th century. It's almost been so obvious and intuitive that not much has needed to be said about it. Obvious in the sense that grazing, because of the reduction of biomass, typically in grassy or grassland or foreland ecosystems, that it reduces fire behavior and fire intensity. What's sort of stunningly remarkable is that in California to date, there's really only been one rigorous published study that has looked at fire behavior and the interaction of fire behavior and grazing. Here in this slide, you see some images. This is from John Steckman's work in the late 70s and early 80s up in San Luis Obispo County. The emphasis of this here, he was examining how a producer might protect his or her ranch from fire moving onto it. So he looked at grazing, mowing, and disking and burning in strips along the boundaries of ranches as all as tools to protect the larger ranch from wildfire moving onto it. And through that work, he did look at wildfire behavior, or I should say fire behavior, in the context of sort of grazing and no grazing. So he wasn't even specifically looking at grazing and how it augmented fire behavior, but this is the most information that we currently have about, again, that interaction between grazing and fire. And because there's been, increasing interest in wildfire in the last couple of years due to the scale and intensity and frequency of fires, I've had the fortune of being able to participate in 2 projects that I want to talk about today. They're listed here along with my co-authors, the formal titles of the projects. The first is a project sort of co-led by Davy Rao, Felix Ratcliffe, and Sheila Berry, and is really sort of a desktop exercise looking at how the implications that cattle grazing has on fine fuel reduction across the state. And the second project that I'll talk about is an in-field project, and it's currently being executed. So I don't really have results, but I wanted to lay out sort of what we're thinking and how it's being executed. And perhaps next week you can get your feedback. But that's that quantitative assessment of range use effects on fire behavior. So to begin to talk about that sort of desktop exercise, thinking about how cattle and grazing reduce fine fuels across the state, that project really asks three basic questions. The first is, how much fuel is removed by cattle through grazing, and how does this amount vary across region? The second question is, how then do fire behavior models tell us about how effective current grazing levels are at altering wildfire behavior? And the third question is, how do sort of the spatial patterns of this grazing and the fuel reduction within regions inform our understanding of the impact of cattle grazing on fire behavior? So answering that first question, how much grazing is there and how much fine fuel is being removed, was remarkably difficult to execute and accomplish. For the purposes of this work, the state was broken up into these 6 regions. There was a logic behind these regions based on both sort of similar production capacities, but also connections that single operations have in terms of where and how they move animals throughout the year. And here are some preliminary results broken out by region. On the y-axis there, we have pounds of fuel removed per acre. And then we have our 6 regions, in the southeast interior, all the way there to the right, on a per acre basis, about 200 pounds per acre is removed annually, all the way up to the San Joaquin Sierra region, where upwards of 1,000 pounds per acre of biomass is removed every year. What I want to emphasize here is that this is on grazed acres of rangeland. This next graph are those same figures, but extrapolated across all rangeland acres, emphasizing here that, of course, not all acres of rangeland in the state are grazed. And so when you extend or expand that grazing impact, not just on the grazed acres, but on all acres, those figures really drop. So the scale bar has changed on the y-axis, and here you can see the South Coast and the Southeast interior on a per total rangeland acre has really very minimal grazing, because there's frankly not a lot of acres of rangeland that are grazed in those 2 regions. And so here are some of the numbers. There are 1.8 million beef cattle that grazed in California in 2017. They consumed on a statewide basis 11.6 billion pounds of fuel or herbaceous biomass. According to county crop reports and a few other sources, grazing happened on about 20 million acres of rangeland in California. That's about a fifth of the state. And the average across the whole state was about 600 pounds. So now that we know how much fuel cattle are removing, what does that mean looking at some of the fire behavior models? And so the first thing that we were able to confirm is that using the numbers that we generated, that really does meaningfully alter fire behavior, at least in the models that are available to us. Another conceit that we were interested, or sort of a premise that we were working under, is this idea of the fire behavior hauling chart. In the fire suppression world, there's a really clear distinction, at least in their training, between flame lengths that are above and below 4 feet. And keeping flame lengths below 4 feet has some really meaningful implications for how fire is fought, specifically that it can be fought on foot with hand tools, and flame lengths above 4 feet make that fire behavior much more dangerous to fight on the ground and really require supplementary equipment. The modeling suggests that during the dry summer months on flat ground across a range of different wind speeds, that we can keep fire below 4 feet if we graze down to 1,200 pounds per acre of biomass. And later in the summer or in the fall, when you have those very dry conditions, that it really requires grazing down to about 800 pounds per acre to make sure that flame lengths remain below 4 feet. What does that mean, or what does that really look like on the ground? I know that these images are frustratingly similar, but I do think that they emphasize an important point. On the left column, you see pasture that's grazed down to about 800 pounds per acre. And on the right, pasture that's grazed down to about 1,200 pounds per acre. And the distinction is quite small, actually. Hundreds of pounds per acre may seem like a lot, but visually across a landscape, it's just sort of slight incremental differences. But hopefully this gives you a sense of what grazed rangeland needs to look like in order to keep flame lengths below 4 feet, at least according to the models. And this third and final question that we asked in this first project, what are the spatial patterns of grazing across the state look like, and what does that mean for fuel reduction in the context of wildfire? And here I think we get to some interesting conclusions. The first is just the very sort of obvious but important point to emphasize, which is that there's really significant spatial and temporal variability in both where biomass gets produced from year to year, how grazing reduces that biomass, what that fuel reduction looks like, how shrub encroachment is moving into grasslands or areas where grazing might be happening, and then also thinking about residual dry matter, which is again, the biomass left at the end of the grazing season. So as a function sort of the variability of grazing, and how all those things may vary at much smaller, finer scales than the region or county. And of course, this desktop exercise sort of could only sort of work at a scale as fine as the county. To emphasize this point, and this is work that I'm a part of with my colleague Royce Larson on the Central Coast here, this project looked at 43 sites across 20 years on the Central Coast and noted that sort of even in the absence of specifically grazing for fuel reduction, that across those years, 40% of the sites achieved that 1,200 pounds per acre by the early fall, that threshold which keeps flame lengths low. But interestingly, across those 20 years and those 43 sites, not a single site every year had biomass that was as low as 1,200 pounds per acre. So just to suggest that the variability in years and across sites means that it's really hard to achieve some of the thresholds that we've been discussing. This is in part because, and for the producers in the room, they'll understand that grazing on California annual grasslands as you're budgeting for feed resources is inherently conservative, that you need to stockpile feed that will last you into the winter. And so a lot of folks aren't grazing as hard as they might in the context of fire and fuel reduction because they're balancing the feed that they need to support their operation year round. And so what that might mean, given the sort of inherent spatial variability, and also the fact that producers need to save feed for their entire year, is that we really need perhaps to think about more strategic grazing programs that are designed in the context of fuel reduction to reduce wildfire risk. And I don't have the benefit of listening to John's presentation before I've given my own, but I think that he will be talking about this in the context of his work at Rancho Hamul, thinking about targeting pastures or using electric fencing to make fuel breaks, to graze, bigger scale, thinking about grazing at key critical times of the year near the WUI, thinking about annual weather patterns, specifically Santa Ana winds down in Southern California. So grazing in areas that we know will benefit a ranch or a landscape in the context of the direction of those winds, etc. I want to turn now to the second project that I was discussing, and this is that quantitative assessment of range use effects on fire behavior. And while the previous project was sort of a desktop exercise analyzing cattle numbers and consumption across the state, this is also a statewide project, but has an experimental component on the ground. There's sort of two prongs to this effort. The first is the statewide prong, where we're selecting at least 9, but upwards of 12 sites where we will be experimentally manipulating biomass to mimic different grazing levels, and doing that at sites where prescribed burns will be happening, and measuring fire behavior across those different treatment levels. And a similar effort, but on a larger scale, is occurring at the Sedgwick Reserve in Santa Barbara County, which is a UCSB reserve. And here, those different grazing treatments are at a much larger scale, and will be burning, or we will basically burn twice now, in fall 2020 and again in spring 2021. We're focusing specifically on fire behavior in the grassland or herbaceous vegetation type. And like I said, we're examining live fire behavior across a spectrum of biomass levels, levels that are intended to mimic a light, moderate, and a heavy graze. The fire behavior metrics that we're interested in are rate of spread, so how fast fire is moving, flame height, which I talked about a little bit already, and then fire intensity as a measurement of the temperature of the flame, using temperature sensitive paints on aluminum strips that we place at ground level. And then at Sedgwick in particular, we're also measuring pre and post fire vegetation composition, and we are doing some soil seed bank work. This is an image that I took just a few days ago of our site in Santa Barbara County. So each of these strips represent a different sort of grazing treatment, although I will admit we were unable to use actual domestic livestock to achieve these different grazing levels. So instead, they are mowed to different heights and then raked to remove the biomass. But this gives you a sense of the scale that we're working at. Those are T-posts to give you that sense of scale. This is a schematic of the way that our site is laid out. We have 4 treatments. You can see them listed from T4 down to T1. T4 represents unmanipulated grassland, and all the way down to T1, which is mowing down to a very low level, raking quite hard to mimic that heavy graze. And for each of those 4 treatments, we have 3 replicates and 3 plots. And these are some images from last fall. I hope that they get you excited to think about the importance of this work. So here in the 4 quadrants, you can see T1 through T4, and you can get a sense of flame heights in particular. You can get a sense of what those treatments actually look like. And I want to draw your attention, of course, to the lower right-hand corner, where in that unmanipulated, ungrazed treatment, you see some pretty dramatic flame heights. That T-post is at least 4 feet high, 120 centimeters. And you can see flame lengths well above that. And that these results just visually held throughout the course of across all treatment strips. And so I anticipate there being some very powerful results that will come out of this work that will help inform our understanding of fire behavior with these different grazing treatments. While we have the image up, I do just want to emphasize, and you can really see this in the T1 image, the patchiness and the sort of patchy nature of the burning. The soil seed bank work will bear this out, but for me, one observation has been that there may be some interesting implication in terms of the seed bank's resilience to fire, the fact that not every square inch of these plots were burned or burned with a high intensity. But we're still working that out to understand what the soil seed bank implications will be across these different biomass treatments. So what are the potential outcomes of this work? I've mentioned some of them, but we're hoping to derive a relationship between biomass per acre and rate of spread and flame height. That we're also hoping to understand how the relationship between fire behavior and some of the other variables I didn't mention in the schematic, but all of our treatment strips have both a slope and a flat component. And we were also, of course, burning under different conditions, temperature, humidity, wind speed, etc. I talked about the soil seed bank work, really trying to understand how more or less resilient these range ecosystems are under different intensity of fire. And at the end of the day, what I'm hoping that this work can help inform are some grazing recommendations, because now across the state, we're working in sort of a vacuum. We really don't know what to tell agencies or landowners or producers in terms of how hard you need to graze to be able to really mitigate wildfire impacts. And I think that this works two directions, making sure that we graze hard enough to really reduce fire behavior. But in some respects, we may think that we need to graze harder than we do. I've heard anecdotes of agencies and cities and municipalities telling grazers to graze down to dirt because that's what they think is the only safe way to prevent fire. And some of this work, I think, is really demonstrating how much less fire you have, even with just a little bit of grazing. And so with that, I'll conclude. I hope I haven't gone too long, and I'll look forward to the discussion in a week's time. Thank you.